All right, we learned about the substitution rule. Time to put it into practice. Okay, so what are we going to select as u? Well, this is where the art comes in, but generally, again, if you have a polynomial, you select the polynomial of highest degree, x cubed plus 5. And so then now what I'm going to do is differentiate this implicitly. Differentiate this implicitly, I get 3x squared dx. And so then if I think about how this is represented in my integral, right? My integral would transform, okay? So u is this bit in here, and then du would be dx and x squared, right? So then only the 3 is present. So what I'm actually going to do here is I want to only see what I need to substitute into my integral. So I'm going to isolate from the derivative chunk. I'm going to isolate the part that is represented in my integrand, and so then I'm going to move the 1/3 or the 3 over to the other side. And so in the place of x squared dx, I would replace it with 1/3 du. Okay, so in all I would have u to the 9th, right? This is u to the 9th times, and then 1/3 du. Okay, just rearranging slightly, 1/3 comes out front, u to the 9th du. Integrate this as normal. I'd have 1/3 u to the 10th over 10 plus c, and I'm not done, right? I've finished integration, but again, I began in x, I need to end in x. So this is going to be 1 over 30 with the constants, and then x cubed plus 5 to the 10th plus c, and I would be done with this one. Okay, so again, select your u, do the differentiation, figure out what you can substitute in for the rest of the integrand, and then once everything is in u, integrate, and then resubstitute in x. All right, another example. Let's see, just thinking out loud here, I think I'm going to let u be square root of x, which is also x to the 1/2 power, because then if I look at du, this is 1/2 x to the minus 1/2 dx. But if I represent that a little bit differently, this would be dx over square root of x times 1/2. Or if I move that 1/2 over, I'd have 2 du is equal to dx over square root of x, which is right in there. Okay, so I think this whole thing with u substitution can transform into integral sine of u times 2 du. Okay, pull the 2 out. Integral sine of u du. This would be 2 times negative cosine of u plus c. Substitute back in. We get a final answer of negative 2 cosine square root of x plus c. Okay, and the other thing too is, since this is an antiderivative, if you want to make sure you did it right, differentiate it. Okay, next one, tangent. Oh, I love tangent, because this one is really weird. Like, you're like, well, is u just tangent? But then if you differentiate, so this is one instance where u substitution might fail. So you try u is equal to tangent of x, and then du would be secant squared of x dx. But then you're like, well, wait, that doesn't work, right? You don't have a secant squared, so you can't do this, right? And then you sit there and you cry a little bit, and you're like, what am I doing wrong with my life? And then you remember, oh yeah, tangent can be represented as sine of x over cosine of x dx. And then you're like, oh, cosine and sine are derivatives. And if I differentiate, and cosine, so like, if I differentiate sine, I get cosine, but cosine's in the denominator, right? So that would fail. But if I try to u that is cosine, then du would be negative sine of x dx, and I just move the negative over to the other side. So then what do I get? I get integral negative comes out in front, dx, sine of x dx would be du over u. Oh, okay, so this is just going to be negative natural log of the absolute value of u plus c. And then this can be negative natural log absolute value of cosine of x plus c. Okay, and then, you know, if you put this into Google, you're like integral of tangent, whatever. Google might give you something different. Remember, the negative can go inside as an exponent on the expression inside the natural log, and if you do that, you would also get natural log of secant of x, 1 over cosine plus c. But either one of these is a valid way to represent the integral of tangent. Yay! Now we know how to find the antiderivative of tangent. Use substitution. Last example for this video is going to be this one. So this looks a little wonky. Okay. Your gut instinct says, you know, to let u be x squared because it's the highest appearing polynomial. Then you're like, wait, there's like two things under the square root, right? That was another thing. So the thing is that if you do this, right, du would be 2x dx, and then there is an x, but it's underneath the square root, so, right, that isn't going to work, okay? And like I said, sometimes you have to try multiple things, so let's try instead the thing that's under the square root of x plus 2, so then du is dx, okay, but what about that x squared? Okay, let me just kind of write this out. So this would be integral of square root of u du. How do I do x squared? X squared. Oh, wait, from here, right, if I isolate x, I could do u minus 2 is equal to x. Does that work? Actually, it's not bad. So remember, u is square root of u is u to the 1/2. So then we can say that this is integral of u to the 3/2 minus u to the 1/2, 2u, I'm sorry, 2u to the 1/2 du, and then it's just undoing the power rule. So you'd have u to the 5/2 over 5/2 minus u to the 3/2, 2u to the 3/2 over 3/2. And then plus c. Okay. And I forgot something, didn't I? Oops, I forgot there's a square here, so I gotta go back and redo my algebra. La-di-da-di-da. Algebra, it will get you every time. Okay, so let's see, this would be u squared minus 4u plus 4 all times u to the 1/2 du. Okay, integral, let's see, this would be u to the 5/2 now, minus 4u to the 3/2, plus 4u to the 1/2, all du. Always remember your differential at the end. Now we can find the antiderivative, which would be, you know, u to the 1/2, and u we said was x plus 2. I'm going to do two steps at once, so this would be 7/2 over 7/2 minus 4, and then x plus 2 to the 5/2 divided by 5/2, and then plus 4u, oops, but u was, and I've been doing it all along, x plus 2 to the 3/2 over 3/2 all plus c. Okay, and yeah, you can simplify it. I don't feel like it. There you go. Okay, and there is an integration gateway this term, just like there was a differentiation gateway. And so when you encounter the integration gateway, if you leave your answer just like this, still full points, and actually it's easier for grading purposes. So please leave your answers just like that. Okay, so we saw a few different ways of implementing in the u substitution with indefinite integrals. Next video, we'll see a few more examples.